everyone. For a geometric sequence a sub n, with the first term is 2 and the third term is 18, we're going to find the value of n such that the sum of n equals 122. So we just have to find our n. What is this value right there? All right, so basically let's see what our r is. Let's a sub 1 is your first term, which equals 2. So a sub 3 is basically your first term times the common ratio that's been multiplied 2 times to the first term. So this is your first term, this is your second term, and this would be your third term. Let me put a 2 there. All right, so basically I can use substitution because we have our first term is 2. So we have 2r squared equals our third term, which is 18. So r squared equals 9. Therefore, r equals plus or minus 3. Since we have that, let's check when r is 3. So when r is 3, we're going to have s sub n equals your first term, which is 2, and we have 3 to the power of n minus 1, divided by 3 minus 1. So this just equals 1 there. So we have 3 to the power of n minus 1 equals 122 right here. Now that means we have 3 to the power of n equals 123 when you add both 1 to both sides. But there's no integer n, and n needs to be an integer, that equals 123. So let's try, this one's not going to work. Let's try when r equals negative 3. That would be s sub n equals 2 times negative 3 to the power of n minus 1 divided by negative 3 minus 1. That equals 122. This is going to be negative 4. So basically we're going to have s sub n equals, I'll just put negative 3 to the power of n. Let me do it this way. Minus 1. This is negative 4. Then this is going to be negative 1/2. And if you multiply both sides by 2, you're going to get negative 2. You're going to get negative 244. Okay, so add 1 to both sides. You get negative 3 to the power of n equals negative 243. So that's going to equal negative 3 to the power of 5. All right, since these two match, our n equals 5. So therefore, n equals 5. Thank you. Have a nice day. Bye-bye.